So we know what the capability ratio is. Okay. Now we're going to understand what is the capability index. Okay. And why one is different than the other one. Okay. So capability index. Here, we're not looking only the size of the garage. We're actually looking at how good the driver is at the same time as we're looking at the size of the garage and the size of the car. Okay? Well, what does that mean? It means that we're going to divide the car in the middle and we're going to look at the middle until it gets to 3 standard deviation to one side, the middle until it gets 3 standard deviation to the other side. Okay, and see how many, what is the sigma level, right? If that fit into the space of the garage. So here the formula is a little bit different. It's divided, the 3 standard deviation one side and the other, and the size is also divided. So I'm looking at the lower, the x double bar, which is the mean of the distribution, minus the lower standard deviation, so the distance between the mean and the lower specification limit, and I'm dividing it by 3 times the standard deviation. Okay, so if I want to know if, from the mean of my distribution until the lower specification, and I divide it by half of the car, I want to know if that fits half of the car or not. And then I take a look at the right of the car, and see if the space between the mean and the upper specification limits divided by 3 times the standard deviation, which is the size of the car, so the size they have available on the garage, the width of the car, if that fits half of the car, yes or no. And the CPK, or the index, will be the minimum of those two, so the lower value. Why is that important? Because now I can understand if it fits to the right or if it fits to the left. Okay? The CP, where we were before, it's just the size of the car. So we go back to the formula, is just upper and lower specification divided by 3 sigma. Okay? So if it was here or if it was here, I wouldn't know. I only know the size match or not with the CPK. The index, it will actually tells me if it's center or not. So if these two values are exactly the same, okay, the one on the left and one on the right, it means that it is center. It is symmetrical, and the mean is actually the middle point. Sorry, on the between the upper and lower specification limits. If one is larger than the other, it means that it shift to the right or shift to the left. Okay. But the answer is the same way that we interpret. If it's 1 or more, it's good in a 3 sigma level. If it's 1.33 or more, it's good in a 4 sigma quality level, 6, 5, or 6 as well. Okay, so let's take a look to see how it looks like. Okay, what's going on here? Is it mean center or shift to the right or to the left? So it's very mean center. You can see that the driver is very good. It's exactly mean center. You have the same distance to the right, the same distance to the left as to the mean of this distribution, and to the upper and lower specification limits. So it's more than 1, right? We have extra space here, and it's mean center because these two values are the same. What's happening here? Well, the CP was higher than 1. What does that mean? Capability ratio more than 1. It means that it can fit based on the size of the car. So the car is good, is in the right size. It can fit into 3 sigma level, but it is not mean center. Okay? So what does that mean? It means that the car is a little bit to the left or a little bit to the right. This case, a little bit to the left. So the car is in the right size. The driver is very good or driving under the influence here and actually crashed in one of the walls again, making everything crumble. Okay? So it is good size, but because we're too much to the left, you have here a lot of defects that you generated. Okay, so it could be a 3 sigma level if you mean center, but now it's not a 3 sigma level because you have a lot of problems going on here that are lower than it's supposed to be. And you can see that because the CPK was 0.86. So it's the minimal value between those two, right? So, okay, what is that telling us? That the distance between this and 3 standard deviation is here, okay? And it's supposed to be here before the lower specification limits, okay? The distance between the mean and 3 standard deviations is good, right? That's 1.43. That's the 0.43 is here, but the 0.14 is what we're leaving behind here. Okay, so what does that mean to manager? It means that you need to fix this problem, changing the location. So adjusting the mean. The variation is okay. You need to adjust the mean. Okay. So this is the quiz problem. You guys know what to do. You have here a problem where it gives you upper and lower specification limits. It gives you standard deviation, and it gives you the mean here. So put everything into that formula that we just saw. Calculate the process capability ratio and the process capability index, right? So after this video, do this math, go on Blackboard, answer the quiz. Remember, the quiz is going to be 10% of total grade, so pretty important. And we're going to do some in-class problems with CP, CPK, statistical process control, all that. Here are some hints for the homework assignment on Pearson MyLab. You have problem 26 that you actually have to create Excel spreadsheet from the data, copy the data from MyLab, paste it on Excel. There is like a symbol to do that. And you have to calculate the standard deviation. And the way to calculate is this one, equal stdef point s, and then select the whole data set. It's going to give you the standard deviation. And you can use that standard deviation to calculate CP, CPK for that problem. Okay? And again, remember the values that I said that have to be higher than 1 to be 3 sigma, 1.33, 1.67, and 2. Okay? So hence, to help you with the problem, in class, we're going to do some problems, and I'm going to ask all the questions and do some discussions, and it will be fun. Okay? Thank you, guys.